Alright guys, so I'm not able to be in the classroom again today. I will be back tomorrow, so I do want to cover some new material with y'all anyway. It's not difficult, but we're moving on to the ellipse. And at least for the do now, guys, let's go ahead and go through this. So this right here, they're telling me write the equation for the parabola using this information. So remember, if I was drawing parabola, and you guys have been dealing with these for quite a while now, vertex is at 1, 2, so 1 and 1, 2, so somewhere up here. Directions is at 5/4, which is equal to 1.25. Okay, so it's going to be y is equal to, so it's passing through here, and 1.25 would be under. Okay, so that means that from here to there, guys, remember this is 2, this would be p is equal to 0.75. And since this is the vertex, it's moving up like that. Okay, so at this point, guys, let me go ahead and I guess I should have run the x first. It is moving up, so I know that the x is squared. Okay, and the y minus k, so the 4p goes over here. Okay, so this would be 4 times p, which I know is 0.75, and I'm going to say that 0.75 is 3/4 because it's going to be easier to work with that way. Y minus k. So this is where I messed up a little because I shouldn't have written it this way. Remember, the h and the k are right here, so my k value is 2, so this should be y minus 2, and over here my h is 1, so like that. And here I can see the 4's cancel, so I'm left with 3. 4 minus 2 equals x minus 1 squared. Okay, so I'm going to ask that the tutor now the tutor now pauses the video so that you guys can work on the do now. And you have 2 minutes to work on it. So put the timer on for 2 minutes. Okay. So this is what you all should have got for your answer for the second do now question. Okay, so I'm going to go ahead and move forward here. We're going to start the ellipse, and so this right here is not very important, guys. It just kind of tells us the things that we're going to look for. So like a parabola, I'm going to have a vertex. Unlike the parabola, I'm going to have an h and k, but the h and k will come from the center. So go ahead and remember that because that's going to be key for tomorrow. H and k I get from the center. Okay. I'm going to have vertices. Okay, so this is the vertex. And you're going to have a major and minor vertex. So you'll have both. Okay, and you're also going to have some foci. Alright, so over here, foci, guys, this is just the focus. And we already had a focus with the parabola, but you will have 2 focuses for each ellipse, and we're going to go through the makings of an ellipse right now. So if y'all remember, an ellipse looks kind of like this. So it looks like a an oval shape, and this is kind of like what I want you to be finding already. And so this right here, the very center, is going to be the ellipse, and this is where I find my h and k. So go ahead and mark that on y'all's papers. And you see how it's real big here in the x direction? So that just means that this right here is the major axis. Okay, major axis is not always going to be in the x. I mean, if you see this one, we can see that it's bigger in the y direction, so the major axis is in the y. Okay, and we're going to call the smaller axis here the minor axis. So here, the smaller edge is in the y direction, so the y is the minor, and over here it's smaller in the x, so the minor is in the x direction. Okay. Now there's a couple of other important things here. This right here is going to be called the major vertex, and you're going to have two. One on this side of the center and one on the other side. So two major vertex. Okay. Like I said, one on either side. Right here. And over here, this would be the minor vertex. And these are all important for labeling an ellipse, which is what I'm going to have you do today in my absence. So pretty simple so far. Major axis, major vertex, you're going to have two. Minor vertex, again, you're going to have two. And the last thing here is this point right here is my focus. Okay, and remember, I have two, so you're going to have two focus points. So this is really what I want you to know. Okay. You're going to have 3 points here. You're going to have the center, which has H and K. You're going to have a vertex in the major direction, and you'll have two of these. You'll have a vertex in the minor direction. Again, you'll have two of these, and you'll have a focus. Okay, again, and this one you'll have two. Now, as I move down to this one, there's an important relation we're going to see here. So this is what I want you to also be able to tell me. Okay. The focus, guys. If you see here, the focus is in the big direction. So the focus right here in the big direction is in the Y. So the focus is also in the Y. So as I move down here, guys, a note that you should know is the foci, or the two focuses, they will always be in the direction of the major axis. Sorry. So focus is always in the major, in the direction of the major axis. Okay. Now, as I go through these also, okay, remember, I'm going ahead and drawing it right here. The focus is inside the ellipse. It's not as far as the vertex, okay, but it is in the major axis, because this one I can see the major axis, the bigger side is the Y. That distance from the center to the focus, because I'm not talking about the distance between the vertex and the focus. I'm talking about from the center to the focus. So we'll say that here. The distance from the center to the focus in either direction, we call that value C. Okay? The distance, we're going from the major axis, okay? Because this is the major, the big side. The distance from the center to the vertex in the major direction, we call this A. And the distance from the center to the vertex in the minor direction, we call that B. Okay, so I want you to start to find me the distance to the focus. Okay, now there's a special relationship here. Okay, remember I just said that from the center to the major, I call that A. So this whole distance here, not all the way to C, but excuse me, not to C, but a little bit further from the center all the way over here, that's A. Okay, I can also say A is from here to there, from the minor to the focus. Okay, this is what it all comes down to. Memorize this. My A value is from the major to the center. My minor is from the minor axis to the center. and I call that distance A, call that distance B, and the other distance C. So this is a right triangle, so this is the relationship I have for all of those distances. A squared is equal to B squared plus C squared. So we're going to use this right now to find where's my vertex and my other vertices, okay? And so we're going to go ahead and continue here. So this is my equation, by the way, and we're going to go ahead and break this down in the next few days. But if I were to put this equation in the calculator, this is the way my graph would look. And so there's a couple things I want from here: the center, the vertices, and the foci. So on all the problems that you show me, this is what I want from you. So remember, center is at H and K. So the center, guys, if I look at it, and I'm going to hit on your papers, you can see this is in the x direction -2 and in the y direction 0. So this one's easy, just -2 and 0. Okay, so I want to know the vertices. So we'll start with the major. Okay, so here I see that it's bigger in the y direction. So let's start with that. The major is in the y direction. Okay, specifically here, this is the vertex at -2 and 1, 2, 3, +4. Okay, I also have another vertex down here at -2 and at -4. Okay, so on the actual paper I labeled where is it at. So two vertices, one at -2, +4, and another at -2, -4. Okay, major. The minor is the x. And again, if I look at my parabola, my ellipse here, I see I have one minor vertex at, so I'm going to put a little MV here, at 1 in the x direction and 0 for the y. -1, 2, 3, 4, 5, and 0 in the y direction. So I have 2 points here, -5, 0, and at 1, 0. Okay, so the only thing I don't know is the focus, and this is going to be a little bit tricky. Remember, it has to be in the direction of the major axis, and so this is the major axis. We said the y is the major axis. So this is where my focus is at. Okay. Now, I'm not going to go get into it right now, like what that actual point is. But what I do want to know is the value from the center to the focus. That I do want to see on your paper. Center to the focus. So, this is important here. Okay, so here, from the center to the vertex is A. So this distance right here is A. Or from here to there. It doesn't matter. So if I count this, I go 1, 2, 3, 4. That value I called A. So my major, my A value is equal to 4. Here, from the center to over here is B. So I go 1, 2, 3. My B is equal to 3. Okay, now for my focus, remember I have to use that relationship right here, and I'm going to go ahead and plug in numbers. 4 squared is equal to 3 squared plus c squared. So 16 is equal to 9 plus c squared. So minus 9 minus 9. And when I solve for c, it's equal to the square root of 7. So all I found here is a length. And don't worry about it because it's such a weird number. I don't want to get you confused over here. And so find me this c value for today. And tomorrow when we start breaking this down a little bit more, I will go into a little bit more depth with this. So we'll do another problem here. And so I can see that. Let's go ahead and start with the center here. Center's right here at 1, 2, 3. So at 3, 0. Okay. For the vertices, we'll start with the major and the minor. So first, let's go ahead and just say what these lengths are. So if I can actually count this, 1, 2, 3, 4, 5, 6, 7. So my major is 7, the length at least. And my B value is 1, 2, 3. Okay, now if I actually want to put the points like I did over here, I'll count it. This is one of the vertexes at positive 3 and positive 7. Positive 3 and negative 7 on this one. And over here, 1, 2, 3. So this one's at 6, 0 and at 0, 0. Okay. And if I wanted to find the focus length, again, the focuses would be somewhere over here. Because it's in the major axis. Okay. So my A is 7, my B is 3. So 49 and 9. So minus 9 minus 9. So C would equal the square root of 40. And so again, guys, this is just where I'm going to stop. Let's not talk about what this actual length is from here to there, or the point at least. Right now, all I need you to know is how to find the length. So I'm stopping here, and we will continue to look at this when I am back in the classroom.